Good morning, sir. I'm G. Satika from CSE department. I'm going to explain about the topic classification of solids. Coming to the introduction to classification of solids. Solids are one of the three main states of matter, characterized by a fixed shape and volume. The classification of solids is based on the arrangement of particles and the forces between them. Understanding the classification of solids is important in various fields such as materials science, chemistry, and physics. Here we can see the diagram related to the changes of states. Solid can be changed into liquid and liquid can be changed into solid after freezing it, and solid can be sublimated, then it will convert to gaseous state, and gas is also converted into solid. Liquid can be converted into gaseous state through boiling, and gaseous state gas can be converted into liquid by condensation process. Now let's discuss about the classification based on atomic arrangement. Crystalline solids have a regular repeating three-dimensional pattern of particles. As here you can see in the diagram, here they mention regular repeating three-dimensional pattern of particles. And coming to the next, amorphous solids lack a regular arrangement of particles and have a random structure. Here you can also see this diagram of this regular arrangement of particles and have a random structure. Next, polycrystalline solids consist of multiple small crystalline regions with different orientation. Simple cubic, body centered cubic, here we can see their examples as well. Coming to the crystalline solids can be further classified into four types: molecular, metallic, ionic, and covalent. In molecular solids, particles are held together by weak intermolecular forces. Metallic solids consist of metal atoms held together by metallic bonds. Coming to the most important one, ionic solids. Ionic solids are composed of positively and negatively charged ions held together by electrostatic forces. They have highly melting and boiling points due to strong ionic bonds. Common examples of ionic solids include table salt and calcium carbonate also. Here clearly we can see the diagrams of ionic solids and how they are bonded. Next, coming to the covalent solids. Covalent solids are held together by strong covalent bonds between atoms. They have high melting points due to the strength of covalent bonds. Diamond and quartz are examples of covalent solids. Coming to the metallic solids. Metallic solids are composed of metal atoms held together by a sea of electrons. They have high electrical thermal conductivity due to the mobility of electrons. Examples of metallic solids include copper, iron, and gold. Chemical bonding in crystalline solids. Here we can see ionic bond, covalent bond, metallic bond, van der Waals bond also. Here they gave every bond's example as well. We can see thoroughly. Coming to the amorphous solids lack a definite shape and have a disordered structure. They do not have a sharp melting point like crystalline solids. Examples of amorphous solids include glass, plastic, etc. Crystalline have like very electrons are very nearly bonded and polycrystalline amorphous. We can see the clear pictures here. Coming to the polymers as amorphous and crystalline solids. Polymers can exist in both amorphous and crystalline forms. The arrangement of polymer chains determines whether a polymer is amorphous or crystalline. Crystallinity in polymers can affect their mechanical properties. Here we can see crystal versus glass molecular structure. Crystal and glass. Crystalline materials have an ordered molecular structure, and amorphous materials have a random molecular structure. Coming to the comparison of properties among different solid types, crystalline solids tend to have higher melting points compared to amorphous solids. Amorphous solids are often more transparent or translucent compared to crystalline solids. The electrical conductivity of solids can vary depending on their atomic arrangement and bonding type. Finally, coming to the applications of solid classification. The classification of solids is essential in materials design and engineering. Understanding the properties of different solid types helps in the development of new materials. Solid state chemistry and physics rely on the classification of solids for research and technological advancements. Here we can also see classification of solids table. Thank you, sir.